Hey, this is Aaron.
And Blake, we're AV Data.
Thanks for walking through this Alteryx Weekly challenge with us. In this video, we're taking a look at Alteryx Weekly Challenge number 242. Here we're looking at a world full of Alteryx offices. So we're provided the latitude and longitude information for 19 Alteryx office locations around the world in 4 regions. We're going to want to find the centroid of each of our regions that we see on the screen. Then find the single office location that's closest to that centroid, and then calculate the distance from the region centroid office to each individual office in miles. If you'd like to follow along, we're on the Alteryx community under Academy and Weekly Challenge. Number 242. Go ahead and download the start file if you'd like to follow along. We're given a relatively simple data set for our input, Weekly Challenge 242. We have 1 field and 19 records. All of our information about these office locations is jammed into one cell, so it's going to start with a parsing exercise. If we think about the Create Points tool from the spatial category, we need to have the latitude and longitude existing as separate fields. So we're going to want to parse all this information into separate fields, and there is no better use case for the regex tool. So looking at our string field of locations, we can use the output method of parse, and by defining marked groups in open and closed parenthesis pairs, we can create some new output columns based on string patterns. So the first bit of information as we work from left to right, we see the city name. And right after the city, we have 2 uppercase letters that denote the region. So we want everything up until 2 uppercase letters in a row. So we're going to use the any single character 0 or more times, dot star, to indicate that we want all characters up until these 2 uppercase letters. Let me correct my parenthesis locations. So now we have 2 marked groups. The 2 uppercase letters are the region code. So I'm going to update my output column name to reflect that we have the city and the region now identified, but we still need our lat and long. So it looks like we want all these numbers up until an x that separates our 2 values. But if we look closely at some of our locations, some of these values actually start with a minus sign. Working with spatial data across different hemispheres, we're not going to only work with positive latitude and longitude information. So here we can signify that the minus sign is optional, so 0 or more times. And then there will be digits, so any character 1 or more time up until we get to a lowercase x. And notice that the lowercase x is outside of our parenthesis groups. So that acts as a marker to help break these 2 values apart into separate fields, but we're not actually creating an extra field that just has an x in it. We don't need to pass it along. But a very efficient way of parsing multiple values out of one string field. And now that we have the latitude and longitude existing as independent fields, we can use the Create Points tool to visualize these spots on the map. So here we click on the centroid, you see the highlighting change in the configuration panel. One item to note is that the latitude and longitude for Irvine and Broomfield looks like they've been flip-flopped. It won't impact our final analysis, no big deal, but just something to note as we explore our data. So ultimately we want to group by the region codes, and for each of our 4 regions we want to find the centroid or the center point, and then figure out which office location is closest to that center point. The Summarize tool, the superhero amongst the transform tools, has tons of great functionality, not the least of which is its ability to spatially process some data. So we can group by the region code, go into the spatial actions category, and create a centroid. So we have a variable number of offices in each region. In fact, in Latin America, we only have one office, so the region center should just be in Sao Paulo, where our one office is. But in the US, for example, it's showing our centroid somewhere in northern Missouri. Looks like lost between Columbia and Kansas City. So just based on the geographical information, finding the centroid puts us somewhere in northern Missouri, but if we actually find the nearest Alteryx office, it will very likely be Chicago. So the Find Nearest tool will allow us to take each of our 4 targets, the centroid for each of our 4 regions, and then we'll take all of our office locations and pass them into the universe, or the U input. And this tripped me up the first time I tried to solve this problem. It cost me a few precious minutes. But if the maximum distance is not large enough, some of the nearest office locations will not be found. All right, so out of the M, or the matched node of the Find Nearest tool, we found one office location that's closest to each of those region centroids. So now we've got 2 colors showing up in our map. We've got the red dot, which is the centroid of each location, and then the green dot, which is the nearest office to that location. And we don't need all of this information, but based on the region, we need to join back to our main data set and map in the office location that is closest to the region center. And we can think of that as our region HQ, just for this little mini problem, or the region center location. So from our join, we really don't need very many fields overall. So I'm going to go ahead and deselect all. And then let's go back and just pick up those few fields that we do need. So the city name is important to us. The region name is important. We will need the centroid information of the actual head office location. So we'll want to make sure that we bring those spatial objects along. So first I'll show the region center, which is the centroid created by our Summarize tool. But ultimately we'll calculate the distance based on the office location. But it might be interesting to see that region centroid on the map relative to all of our office locations. So here the red dots showing up were our Alteryx offices, and the green dots are the centroid of each of our regions. And in order to get them to sort the way that we want to see the region as our first field. And again, the green dots here are the centroid of the individual regions. But when it comes to calculating our distance, we don't necessarily care about the centroid. We're going to use the office that is closest to that centroid. So for the APAC region, we're going to start in Singapore and then calculate our distance from the Singapore office to the Tokyo office and Singapore to Sydney. So quickly revisit my join tool, make sure that we're bringing the proper spatial objects along so that we can process them downstream. So now we have 2 spatial objects, the region HQ centroid and the centroid. We just want to calculate the distance between them. So the distance tool will allow us to quickly calculate either in miles or kilometers. I believe our output is looking for miles. So we don't need to worry about the cardinal direction Now that we've calculated the miles, we can even drop off our spatial object fields and wrap up our weekly challenge. So lots of great logic on the canvas and not very many tools at all. If we think about it, it's quite an efficient process. First, we're going to parse our data and create points. Then we'll actually group by the region and calculate or find the centroid for each region and find the nearest office to that centroid location. And finally, join our results back and calculate our distances. Thanks for following along.
Thank you for learning with us today. Good luck on your Alteryx journey.
For more information on custom training, managed service automations, and more, please visit our website at abdataconsulting.com.